Hello, method students. The two last PowerPoints of the semester will be done with VoiceOver. I hope it works well for you. It's a little bit sad for me to be doing my lectures in front of a computer instead of in front of you. It's weird because I'm in my car right now. I'm recording stuff in my car. It's the only quiet place I can find. So let's go. There's no VoiceOver on each slide. Some slides are so straightforward that I don't need to record my voice, but you will see an icon to click on when there is VoiceOver. First, let me remind you what a sample is. You have learned that in Methods 1. A sample is a part of the population. It's a group of individuals or a group of subjects that is supposed to represent the population. It represents a smaller or a bigger percentage. In social science, we usually select samples instead of using entire populations because first of all, getting information about the entire population would be very difficult, very expensive, and, well, impossible in most cases, and not necessary, in fact, because a good representative sample works really well. Samples have to be as representative of the population as possible. Representative samples have two main qualities. First, they're large as possible. As you remember, the larger the sample is, the lower is the margin of error. And you want a low margin of error for your study to be a good study. The second quality of a good sample, it's random. Random sampling means low bias, and you want bias to be as low as possible. However, in some types of studies, it is not necessary or not desirable to have a random sample. We'll talk about that. The first step in selecting a sample starts even before doing a sample. It's to have a very good and precise idea of what your population is. Remember, your population means those you want to study. So I want to study heritage students. I want to study all Canadian adults. I want to study BMW owners in Gatineau. So these are populations, and when you target your population really well, then you're ready to select your sample. The second step is to find a sampling frame when possible. A heritage students list from the student services would be a sampling frame. Voters list would be a sampling frame. Customers list at a car dealer would be a sampling frame. So a list that as much as possible includes your entire population. If your sampling frame does not include your entire population, it will create what we call undercoverage, and we don't want that. Sometimes we can't avoid, but as much as possible, we want to avoid that. For some sampling methods, especially non-random sampling methods, there is no necessity to have a sampling frame, no necessity to have a list. It depends. But for any random sampling method and some of non-random sampling methods, you need your list. You need your sampling frame. As you remember from methods 1, random sampling methods give each individual of the population an equal chance of being chosen. Random samples reflect the population really well. You can avoid bias, and we can infer conclusions from a random sampling method. We'll see 3 of them: simple random sampling, stratified random sampling, and multi-stage cluster sampling. There is a slide for each of these methods, so I will explain them one by one. When you use a non-random sampling method, it means that each individual in your population is not given an equal chance of being chosen. Sometimes you will use a non-random sampling method because you just can't possibly use random sampling. Sometimes you will use a non-random sampling method because you choose it, because it's not desirable to have random sampling. We'll see that. I will explain 5 types of non-random sampling methods: quota samples, accidental, convenience, snowball, and purposive samples. Each one will be explained in a different slide. You have learned simple random sample in methods 1, so you know it really well. I don't have to explain in length. But for doing a simple random sample, a SRS, you need first to have a sampling frame. You have to know exactly how many subjects you have in this sampling frame, and you have to label them. You have to label them with numbers, and each of these numbers need the same amount of digits. So if you have 300 individuals in your sampling frame, the first one will be labeled 001, the second one 002, up to 300. And then you will use either a table of random digits or most likely an online randomizer to select your sample. Stratified random sample that you probably have learned in methods 1 is another kind of sampling method in which you want to cover as well as possible different strata in your population because you judge it is important in your study. For example, if I have a population of 1,000 individuals and only 1/4 of my individuals are women, I want this proportion to be well represented in my sample because it's important for the sake of my study. If I use a SRS's coincidence is totally random. I might end up with only 2 women or no women at all in my sample. And I want the original proportion of my population to be respected. So what I will do, in my sampling frame of 1,000 individuals, this sampling frame, I will separate it in 2 different sampling frames. One for men, here in this case 750 men, and a different sampling frame for women, in this case here 250 women. And if I want my sample to be composed of 100 individuals, I will pick 75 men in my sampling frame of men, and I will pick 25 women in my sampling frame of women. In such a case, the original proportion of genders of my original population is well represented. In a stratified random sample, each individual is still given an equal chance of being chosen. Multi-stage cluster sample is a little bit trickier. It's when you go step by step by dividing your population into smaller groups. First step in doing a multi-stage cluster sample, you define your population. For example, if I want to survey all first-year social science students, this is my population. Second step, I find a way to divide my population into smaller groups. In this example here, I know that all first-year students take Methods 2 right now. So there are 8 groups. I could select randomly 3 of the 8 Methods 2 groups. Then I will go even smaller. In each of the 3 groups I have randomly selected, I will randomly select, let's say, 10 students in each of the 3 groups. So I will end up with a sample of 30 students among all my first-year Methods 2 students. This is a multi-stage cluster sample. Another example, if I want to survey the population of the United States, I know there are 50 states, so I will randomly choose 10 of the 50 states, and in each of these 10 states, I will randomly select, with voters list maybe, 100 citizens. So I will end up with a random sample of 1,000 citizens of United States using a multi-stage cluster sampling method. This is a good way, for example, to have a nice representation of a broader geographic area. The first non-random sampling method, you know it already, it's called convenience sample. It's when you, the researcher, select your sample using an easy way. This happens when you do not have access to a sampling frame. It is the case, normally, of Methods 2 students selecting their sample to answer their survey, to fill their survey. So they go around the college and they ask students to fill out the survey. So this is a convenient sampling method. They do that because it's not possible to have legally a sampling frame. Student services would not disclose it, so they cannot do random sample. There are ways to improve a convenient sample to make it a little bit more representative, even if it never gives all individuals of the population an equal chance of being selected. If a student goes only near the gym or only in the library to select a sample of 30 students, well, these 30 students will look alike. They will have similar traits. So maybe it's not a good way. If a student goes at 6 different places in the college, the gym, cafeteria, library, agora, etc., and chooses students there, 5 students in each of these 6 places, well, it's more balanced. It's a better convenience sample. It's not perfect as a random sample, but at least it is better. So there's ways to do good convenience samples. Another non-random sampling method is called quota sample. It looks a lot like a stratified random sample, except that it is not random. You do quota sampling when you really want to respect some strata of your population, but you do not have access to a sampling frame. So in this case here, you can't do a random sample. So in a quota sample, when you do not have a sampling frame, you try to determine the best you can the proportion of the subgroups in your population. Example, I want to study first-year social science students. I know that about 40% of them are male and 60% of them are female. So I will guess that. Well, let's say it's 50-40. So I will use these percentages when I select my sample. When you use what we call accidental sampling, you use whatever subject is available to be part of the sample. And remember, subjects are not necessarily people. Subjects can be documents. They can be, well, when I do archaeology, subjects are people, but they're skeletons, or they're ceramic vessels, they're stone tools. Okay, so in some cases, you only have access to the subject you can find, and you will use all of them. You accidentally find subjects, and you use as many as you can. It's used in history. For example, if I want to study the correspondence, letters sent by Winston Churchill, and I know the guy sent thousands of letters in his life, and going to Europe and going around libraries and going online, I can find 368 of these letters. Well, these 368 letters will be part of my sample, will be what I use to do my history research. So this is an accidental sample. If many times I had to study burial grounds of pre-Inca populations, and I had no clue how many skeletons were there, but in a season of digs, I find 13, 14. Well, these 13 skeletons will be my accidental sample. I don't even know how many are there, but I will use these I found accidentally to do my research. What we call snowball sampling is chosen sometimes by social scientists when they study people that are kind of hard to find, or people that are that don't want to be studied. For example, if I want to study Hells Angels, official members of the Hells Angels, well, it's kind of hard to get a sampling frame. No one will give me a list of these guys. So I will try to infiltrate, to make friends, and to do like that. Well, it's unlikely I use that topic for a study. Let's find a better example. Imagine I want to find people. Oh, my son is allergic to chocolate. Poor guy. So I want to study these people for medical study. But I have no clue who in the population is allergic to chocolate. So I will go to my allergologist and I will ask him, do you know some people allergic to chocolate? Oh, yes, I know 3 of them. And I will contact these people and I will ask them, do you know some other people that are allergic to chocolate? And slowly, by, people to people, I will maybe be able to collect a sample of 13 individuals in the population that are allergic to chocolate. It is absolutely not a random sample, but it's the best I can do. More generalized group as well will be studied, and researchers will use snowball sampling to contact them. So you use your contacts to gather as many individuals as you can in your sample. Purposive samples, also called judgmental samples, are used on purpose when using a random sampling method will not help your study at all. It's better actually sometimes not to use a random sampling method. The best example I can give you is a few years ago, one of my Method 2 students was studying princesses in Disney cartoons, and her goal was to find differences in traits and behaviors between racialized princesses and white princesses. So imagine, and she had time to watch about 10 Disney cartoons. So imagine if she selected among all Disney cartoons 10 cartoons at random. Chances are the 10 cartoons in her sample would involve white princesses. So what she did, she separated all Disney princess cartoons in 2 groups. One group with white princesses and one other group with racialized princesses. At that time, if I remember well, 6 Disney cartoons had a non-white princess. So she used these 6 cartoons, and among all the cartoons depicting white princesses, she randomly selected 6. What she did was a judgmental sample. She on purpose selected some of the subjects to be part of her sample for the sake of her study. This is called a purposive or judgmental sample.